Traditional factory automation lacks adaptability and efficiency. Current automation systems are limited in their ability to handle complex and dynamic manufacturing processes. To address this, we propose integrating quantum principles into robotics to enable enhanced factory automation. In order to grab your attention, it is important to highlight the limitations of traditional automation systems in meeting the demands of modern manufacturing. Quantum robotics can revolutionize factory automation by leveraging advanced computational capabilities and adaptive decision-making. By adopting quantum robotics, factories can benefit from increased efficiency, flexibility, and productivity in their manufacturing processes. It is crucial to showcase these benefits to create a desire for the adoption of quantum robotics in the manufacturing industry. To take action, we advocate for the adoption of quantum robotics to drive innovation and competitiveness in the manufacturing industry. Let's now explore how quantum principles can be applied to solve specific challenges in robotics. One common problem in robotic systems is the lack of coordination and collaboration capabilities. This limits their potential to perform complex tasks efficiently. By applying quantum swarm intelligence principles, we can enable collaborative robotics that enhance coordination and cooperation among robots, leading to improved task performance and efficiency. Another problem in robotics is accurate perception and understanding of the environment. Limited perception capabilities hinder the ability of robots to perform complex tasks autonomously. Quantum sensing principles can be utilized to enhance the perception and awareness of robots, enabling them to navigate complex environments, detect and avoid obstacles, and interact more effectively with humans and objects. Decision-making in dynamic and uncertain environments is another challenge for robotic systems. Limited decision-making capabilities hinder the autonomy and adaptability of robots in complex tasks. By applying quantum decision-making principles, robots can make informed decisions based on probabilistic evaluations and rapidly changing conditions, enhancing their autonomy and adaptability. Additionally, robotic systems often lack the ability to continuously learn and improve their performance. Limited learning capabilities hinder their ability to adapt to changing tasks and environments. Quantum learning principles can be implemented to enable continuous improvement in robotics, allowing robots to learn from experience, refine their skills, and adapt to new tasks and environments.
Attention, highlight the limitations of traditional factory automation systems.
By incorporating these advanced quantum principles into robotic systems, factories can achieve enhanced automation, collaboration, perception, decision-making, and continuous improvement. These quantum